In this tutorial video, I'm going to show to you how we are going to perform operations with radicals. The four fundamental operations: addition, subtraction, multiplication, and division. Let us start. Before we go to the first operation, the first two operations, addition and subtraction, let me first define to you what are similar unlike radicals. These are radicals whose index and radicands are the same. So I think at this moment you already know what is the index, what is the radicand. So again, similar radicals are radicals whose index and radicands are the same. Example, square root of 5 and 3 square root of 5. They are similar because the index is 2, index of the other radical expression is also 2, and the radicand is square root of 5. On the other radical expression, it is also square root of 5. So that's why they are similar. How about square root of 5 and the cube root of 5? It's very obvious. They are not similar. Why? Even though the radicands are the same, square root of 5, but you look at the index. Index is 2, but on the other radical expression, the index is 3. Therefore, they are not similar. How about square root of 8 and square root of 18? I can read your mind and you will answer not similar. But kids, always remember, the world is so deceiving. Before we are going to answer, let us first analyze. Don't you know that square root of 8 can be simplified into 4 times 2, the square root of 4 times 2. So just recall how we simplify radicals by just clicking the link shown above. Now, if we have square root of 4 times 2, 4 is a perfect square, so we can have the square root of 4 is 2. And then for 18, square root of 18 is equal to 9 times 2, the square root of 9 times 2, but square root of 9 is equal to 3. That's why you have 3 square root of 2. Now, you look at our two radical expression, 2 square root of 2 and 3 square root of 2. What can you say? Yes, they are similar. So, again, do not rush your decisions. You analyze carefully. So, example number 3 are similar radicals. Now that we already discussed what are similar radicals, now we are ready to perform the first two operations, addition and subtraction of radicals. So in doing addition and subtraction, it just follow the same idea. That's why we just combine it. Similar radicals can be added or subtracted the same way that like terms can be manipulated. If you can still remember, during your grade 7, you are taught about similar terms or like terms. Example, 2x plus 3x, that is equal to 5x. So how did we come up with 5x? We just copy the common variable, x, and then add the numerical coefficient because they are like terms. So again, copy the common variable and then add the numerical coefficient. That's why we have 5x. And then for subtraction, it follows the same idea. As long as they are similar terms, we just copy the common variable and then subtract also the numerical coefficient 5 and 3. Okay. So let us now apply that idea to radical. Example, simplify negative 3 square root of 5 plus 2 square root of 5. So every time you are given with problem, first thing to do is to analyze, to look at the problem, and plan on how you are going to attack that problem. That's how basic is it. Now, for the problem, it is very clear that they are similar radicals. The same index, which is 2, and then the same radicand, which is square root of 5 or 5. Now, since they are similar radicals, now we can get the common radicand, which is 5. So we can have the square root of 5. After that, we can combine the coefficient. It could be numerical coefficient or a coefficient containing variable. But in this case, these are the numerical coefficient, the negative 3 and positive 2. So we are going to combine negative 3 plus 2. But what is negative 3 plus 2? That is equal to negative 1. And then just copy. Just copy the square root of 5. Now, in mathematics, to make it more beautiful, we can just have negative square root of 5. So we just omit 1 to make it more beautiful, and that's it. Another example, simplify 4 times the cube root of 4 plus 5 times the cube root of 4. Now we analyze the problem, and it's very clear that they are similar radicals. The indices are the same, 3 and 3. Radicand is 4. Now, since it is confirmed that they are similar radicals, then we can proceed because they are similar radicals. So we copy the common radical expression, which is the cube root of 4. And then combine the coefficients are 4 and 5. So we have 4 plus 5. And 4 plus 5, it is just like we are going back to elementary years. So 4 plus 5 is equal to 9. And then just copy the common radical, the cube root of 4. And that's it. And who says math is difficult? It is just as simple as 4 plus 5 equals 9. Third example. Okay. Simplify square root of 5 plus 2 square root of 5 plus square root of 2. Analyze the problem. Square root of 5, 2 square root of 5. So they are similar radicals. But how about square root of 2? So in this problem, the first two radical expressions are like radicals or similar radicals, while the third one is unlike. So what we can do is stick with the rule. Just combine similar radicals. So we can combine, we get the square root of 5 because it is the common radical, and then add. Now what can we add? We cannot see any coefficient before square root of 5. Okay, kids, for your information, as long as you cannot see any coefficient, it means 1. So we can have 1 plus 2. And then just copy the third radical expression, which is square root of 2, because it is still part of the problem. Now combine 1 plus 2, that is 3 square root of 5 plus square root of 2. Now, since we do not have any similar radicals, then it is time for us to stop, because that is already the answer. You know, one of the most common problems is the students tend not to stop because they want that the answer is just a single radical expression. It's not like that. Always stick with the rule. That's it. Example 4. Simplify 10 square root of 75 minus 5 square root of 300. So upon seeing the problem, again, do not conclude immediately that they are unlike radicals or dissimilar radicals. Try to look at the radicand 75 and 300. These are big numbers, and then while looking at these numbers, try to factor. Apply what you have learned in simplifying radicals. You look for perfect squares that are factors of 75 and 300. And then if you just always do this, it's automatic. 75 is 25 times 3. 300 is 100 times 3. So for 75, 25 is a perfect square. For 300, 100 is a perfect square. So let's have the solution. Then, we factor 75 into 25 times 3. This is how we simplify radicals. We look for perfect squares so that we can simplify the radical minus 5. Just copy 5. And then for 300, we are going to factor. That is 100 times 3. And then simplify. If you want to learn more about simplifying radicals, I will just include the link in the description. Now, we have 10. And then, what's the square root of 25? That is 5. So, we have 10 times 5. And then, the remaining, we have square root of 3. Because we cannot extract anymore the square root of 3. Minus 5. Square root of 100 is 10. And then, the same, square root of 3. Now, we simplify. 10 times 5 is 50, square root of 3, minus 5 times 10 is 50, square root of 3. Now it's very clear that they are similar radicals. So that's what I said earlier. Do not decide immediately. Try to analyze. Now, since they are similar radicals, we can now combine the square root of 350 minus 50, and that is equal to 0. And kids, always remember, any number multiplied to 0 is equal to 0. And that's it. Let us proceed to the next operation, multiplication of radicals. So under multiplication of radicals, I categorize the type of solution. Again, in mathematics, you need to know what kind of problem and what specific solution we are going to apply. That is mathematics. So first, we have multiplying radicals of the same order or the same index. So to do that, just apply the product rule for radicals. So if you have the nth root of x times y, it can be broke down into the nth root of x times the nth root of y, and vice versa. And then multiplying radicals of different orders, just change the radicals into same order, because we cannot multiply radicals if they are not of the same order. So to multiply, we first change the exponent into like fractions. Finally, transform back to radical form, then apply the rule above. So in the upcoming slides, you can see how it should be done. Let's have example 5. Multiply and simplify square root of 6 and square root of 2. So operation is multiplication. So we write our expression, square root of 6 times square root of 2. First, we check the index or the order. Since the orders are the same, square root of 2, then we can proceed multiplying. So again, just apply the product rule for radicals. We can multiply it this way. We can have only one radical sign and then multiply 6 and 2. 6 times 2 is equal to 12. But you're not going to stop there. Make sure that your radical is simplified. So when you look at 12, it can be factored into 4 times 3, wherein 4 is a perfect square. Again, when you first deal with this kind of problems, you will have a hard time how to simplify. But if you just continue and you are willing to learn, then automatically, if I'm doing it like lightning, you can also do it in that fashion. So you have equal to the square root of 4 times 3. Now square root of 4 is equal to 2. Alright, and then we have the square root of 3. And then since if you look at our radical expression, it is only square root of 3 and that cannot be simplified anymore. So that's it. Done. Next, the 6th example. Multiply and simplify 2 square root of 8 plus 3 square root of 5 and 6 square root of 8 plus 7 square root of 5. So in this kind of problem, we are multiplying radicals in binomial form. Binomial because we have two terms. So just the same with algebra. When you multiply binomial, just apply the distributive property, or some of us also call it as the FOIL method, or simply the distributive property. So how are we going to do that? Start with the first terms. First term in this binomial, first term in the other binomial. 2 square root of 8 times 6 square root of 8. Again, in multiplying problems like this, multiply the coefficients, multiply the radicals. So in this case, we multiply 2 and 6. So that is equal to 12. At the same time, multiply square root of 8 and square root of 8. You need to check first if they have the same order. Since the order is the same, 2, then we can multiply. So that is square root of 64. So 8 times 8 is 64. Then we proceed. The outer, 2 square root of 8 times 7 square root of 5. Again, multiply the coefficient first. 2 times 7 is equal to 14. And then since the order is the same, 8 index 2. So multiply 8 and 5. So we can have square root of 40. After that, we can proceed with the next term, the inner terms. So we have 3 times 6 is equal to 18. And Since the order is the same again, we can multiply 8 and 5, so that is square root of 40. And proceed to L, the last terms. Last for the first binomial, last for the second binomial. And then 3 times 7 is equal to 21. And 5 times 5 is the square root of 25. So in this example, I'm showing to you the step-by-step process, and if you don't like it because you want the shortcut, then you can do the shortcut. I mean, when I say shortcut, for example, in this case, you have 12 square root of 64. You can just write immediately 12 times 8 because you already know that the square root of 64 is 8. So instead of writing 12 times square root of 64, you can write 12 times 8. But for the sake of discussing it, because most of you watching this is your first time looking into this example. Okay? The next, you look at these two terms. 14 square root of 40 plus 18 square root of 40. They are similar radicals, right? So meaning we can combine the coefficient 14 and 18. If we add that is equal to 32, and then 40 is equal to 4 times 10. That's why we can have 32 times the square root of 4 times 10. 4 is the perfect square, plus the square root of 25 is 5. So you have 21 times square root of 5. So that is equal to 12 times 8 is equal to 96. So in this solution, I will combine 96 and the product of 21 plus 5. 105, because they are all constants. So we can combine 96 and 105 later on. Plus 32. What's the square root of 4? Square root of 4 is 2. And then since 10 cannot be simplified anymore, so we have square root of 10. Now we can combine 96 and 105. So if we add 96 and 105, that is equal to 201. Plus 32 times 2 is equal to 2 times 2, 4, 2 times 3, 6. So that is 64. And then copy square root of 10. Now, you look at the two terms. 201 plus 64 square root of 10. This is one term. This is also another term. You put this one in mind. These two terms are not similar. Why? This is just a numerical coefficient, a constant. But on the other term, it contains a radical expression. To make it simple, we cannot combine terms like that. So that is already our final answer. Example 7. Simplify square root of 2 times the cube root of 2. The problem looks very simple because we only have two terms. Square root of 2 and two expressions. Square root of 2 times the cube root of 2. But if you are going to check their indices, they are not the same. Index is 2, the other index is 3. So, to multiply or to find the product, we need to have the same order. And how are we going to do that? The technique is transform them into exponential. So when you have square root of 2, that is 2 to the power of 1/2. Again, the index will become the denominator. I hope you did not forget that lesson. Then, the cube root of 2, that is 2 raised to the power of 1/3. Because the index is 3, so that will become the denominator. So if we rewrite our problem, square root of 2 times the cube root of 2 is equal to, we copy 2 raised to the power of 1/2 times 2 raised to the power of 1/3 times. Okay. Now if you look at the two exponential expressions, they have the same base. So we can apply the product rule. What does the product rule for exponents say? It says that if they have the same bases, then we can copy the base and then add the exponent. That's the product rule. Instead of, since the operation is multiplication between the exponential expression, we are just going to add the exponent. That is the product rule. Now, after that, in order to have the same index, we need to find the LCD. LCD of 2 and 3. LCD of 2 and 3 is 6, right? So LCD is 6. 6 divided by 2 is 3 times 1, that is equal to 3. 6 divided by 3 is 2 times 1, that is 2. And then you do it like during your elementary, just add, since they are similar fractions, add the numerators. 3 plus 2 is 5, copy the denominator, which is 6. Now after that, we can now go back to the radical expression. So we have the radical symbol. The denominator 6 will become the index, and then the remaining will become the radicand, 2 square root of 5. And to have the final answer, just simplify the radicand if possible. And since 2 to the square root of 5 can be simplified into 32, then that's the final answer. Why 32? You do it this way. 2 times 2 times 2 times 2 times 2. So there are 5 2's, that is equal to 32. And that's it. Let us now proceed to the last operation. Division of radicals. Just apply the rule, the quotient rule for radicals. If you have the nth root of x divided by the nth root of y, then we can write it as the nth root of x divided by y, where y is not equal to 0 because that will make the equation or the fraction undefined. Example 8. Simplify square root of 9 over square root of 3. So, the same with multiplication. For division of radicals, the orders or the indexes should be equal before you can proceed with this rule. So since they are the same, the index is 2, then we can proceed with square root of 9 divided by 3. And 9 divided by 3 is equal to 3. And we have square root of 3, and that's it. Very simple. Example number 9. Simplify 6 minus square root of 2 over 4 minus square root of 2. Now, one thing you are going to remember with division of radicals, just review how we are going to rationalize. You look at my video tutorial about rationalization under simplifying radicals. If a fraction contains a binomial radical denominator, rationalize it by multiplying it by its conjugate. So we have a new term, conjugate. So if we are going to look at example 9, you look at the denominator, it contains a binomial because we have two terms, 4 and the square root of 2. So how are we going to solve problem like this? We are going to rationalize by multiplying it by its conjugate. Now the only problem that we have right now is, what do we mean by conjugate? Two binomial radical expressions are said to be conjugate if they differ only in sign that connects the binomials. You look at the words in bold, if they differ only in sign that connects the binomials. So these are the signs. So when we say terms, these are just separated by plus and minus. So for example, square root of 5 plus square root of 7, it is being connected by plus sign. So to find the conjugate, we just copy square root of 5 and 7. And instead of plus, its opposite is minus. So this is the conjugate. Square root of 5 plus 7, its conjugate is square root of 5 minus 7. Again, they differ only in sign. So if it's plus, then in its conjugate, it should be minus. If it's minus, then its conjugate should be plus. Example, our problem, 4 minus square root of 2. So to find the conjugate, we copy 4 and square root of 2. And since this is the minus sign, on its conjugate, it should be plus. That's it. So, we go to our example. To solve or to divide radicals, just rationalize. That's it. So multiply it by its conjugate. The conjugate of 4 minus square root of 2, as we have in the previous slide, is 4 plus square root of 2 4 plus square root of 2. So what you write on the denominator, it be copied in the numerator. Purpose is the whole of this is just equal to 1. So we are not changing the problem. Now, to solve this, you can apply what we discussed on the previous slide, multiplying binomials. Apply the FOIL method or the distributive property. We start with 6 times 4. So that is equal to 24. Next, we have 6 times the square root of 2. So in multiplying a whole number and a radical expression, just copy the whole number, 6, and then on each side, you write the radical. You cannot multiply 6 by 2. Why? They are not the same. This is a radical expression. This is a whole number. So what you can do is just copy the whole number. On each side, you write the radical. Because in multiplying radicals, again, it should be of the same order. So how can they be of the same order if this is a whole number? Right? And then next, negative square root of 2 times 4. Again, a whole number and a radical, so we write 4. But it will become negative because the sign of the square root of 2 is negative. So negative times positive, it's negative. Negative. That's why it will become negative 4. And then just copy square root of 2. And then lastly, negative square root of 2 plus times positive square root of 2. Again, operation is multiplication when you apply distributive property. Negative times positive is negative. That's why we have negative square root of 4. This time we can multiply 2 and 2 because they have the same index or order, which is 2. So we can multiply 2 times 2. That's why we have 4. For the denominator, it is expected that you are also going to do the same process. But because I love my students, let us do the shortcut. So the shortcut is, you look at the first term, 4, they are the same. So what you're going to do is to square. Always square. Take the square of the first term, which is 4. And then this is also always minus. Remember that, always minus, no matter what, this should be minus. This will not change. And then the next thing is the second term, which is square root of 2. So we write square root of 2 and then square. Square root of 2 and then square. So that's it. Instead of doing the same thing of what we did in the numerator, we can have this shortcut. It's proven to be correct. Of course. So we can have simplified 24. So copy 24 and then observe that they are similar radicals. Square root of 2 and square root of 2. So we can combine 6 minus 4. 6 minus 4 is equal to 2. 2 square root of 2. And then minus square root of 4. But what is the square root of 4? That is 2. That's why we have minus 2. Okay? And then on the denominator, we have 4 squared. 4 squared is equal to 16. Minus. This is always minus. And then square root of 2 squared. We have a property that if the index and the exponent outside is the same, it will cancel with each other. So if we cancel 2 and the square root sign together with the index, we have 2 as the remaining. So square root of 2 squared, that is 2. The square root of 5 squared is 5. That's it. And then simplify. 24 and 2 are whole numbers. So we can combine 24 and negative 2. 24 minus 2 is equal to 22. And then just copy plus 2 square root of 2. 16 minus 2 is equal to 14. Now, you look at each term. 22, 2 square root of 2, and 14. They are all divisible by 2. So in order that our answer is already really simplified, then we can divide each term by 2. So 22 divided by 2 is 11. 2 divided by 2 is 1. So when it comes to this term, only focus on the coefficient, the numerical coefficient. Do not include the radicand. So 2 divided by 2 is 1. So we don't need to write 1, but it's understood to be 1. And then 14 divided by 2 is 7. So Another way is also to factor out 2, and you will just get the same answer. So I'm just doing the wise way. Divide each term by 2. So we have 11 plus 2 square root 11 plus square root of 2 all over 7. And in this form, this cannot be simplified further because we cannot combine 11 and square root of 2. So that's it. So thank you for watching. I hope you learned something. Do not forget to hit the like button, and of course you comment also so that the comment section will not be sad. Bye bye.